Hey everybody, it's Mr. H. In this video, I'm going to talk about adding, subtracting, and multiplying radicals. And just from the beginning here, I want to make it very clear that this video is going to be much more fast-paced than my past videos have been, because now the expectation is that you understand how to simplify radicals and that you understand what a radical is. Cannot stress enough how important it is to understand how to simplify. That should be the most challenging part of everything we do with radicals. If you don't understand how to simplify, frankly, you should not be trying to do this right now. You must understand how to simplify. And once you've got that down, adding, subtracting, and certainly multiplying is going to seem pretty simple. I'm not really giving you many notes here. It's really just examples. So, example 1. Now, I would encourage you right now to pause the video and take a guess what you think it might be. Alright, if you took a guess, we'll see if you get it right. But essentially this is saying if I've got a square root of 10 and I add a square root of 10, now I have 2 square roots of 10. Example 2. Again, you could pause the video now and kind of test yourself here. But this is the same idea as up here. If I have 3 square roots of 6 plus 4 square roots of 6, I have 3 plus 4, which is 7 square roots of 6. Notice I'm adding my numbers that are outside of my radical, and my radicand is staying the same. Example 3. Now, since addition and subtraction are inverses of one another, you should automatically be thinking to yourself that the rules should stay the same, and they do. 10 square roots of 3 minus 2 square roots of 3 is just saying 10 minus 2, which is 8 square roots of 3. And just as a final example, now again, you can pause it, think about that. But if you're wondering, yes, we work with negative numbers, and yes, you're expected to know how they work. In this case, I'm saying 2 minus 5. A 5 is like having 2 plus 3. So if I have 2 minus 5, you can think of that as saying like 2 minus 2, which gets me to 0, but there's still 3 left over. So it's going to go to negative 3 square roots of 5. If you have trouble understanding this, just let me know, and I can pull out some number lines and we can talk about it. In general here, and yes, you should all be taking notes, rules for adding and subtracting. 1. Your radicands, which if you don't remember, the radicand is literally the number that would be in your radical. Those have to match. Must match. If they don't, you can't add or subtract them, period. Notice all the examples we did so far, they all matched. 2. If your radicands do not match, you have 2 possible scenarios. So 2, you can just say possibilities. The first would be you may need to simplify like one or both of them. So you may need to simplify. If you're not sure quite what I mean by that, you'll see soon enough. And then the second possible option, which will sometimes be the case, but you need to make sure that something can't be simplified first. But the second possible option might just be that you can't do anything. And again, I'll show y'all an example of how that can happen. This one is going to fall into the second camp where we can't do anything with it, hint hint. But if I have the square root of 7 plus the square root of 6, that should be throwing up all kinds of red flags. Those radicands do not match. In other words, 7 and 6 are not the same number. No matter what you do to them, they're not the same number. You need to check 6 and make sure that it can't be simplified. I know 7 can't be simplified because it's a prime number. So what are the factors of 7? 7 and 1. That's it. What are the factors of 6 though? 6 and 1 work, but so do 3 and 2. But none of those are squares. So square root of 6 is already simplified. Well, if that's already simplified, then the square root of 7 plus the square root of 6 is just the square root of 7 plus the square root of 6. It's already simplified. Now, if you used a calculator, technically you could turn both of these into like decimals and then add them together, and you could get an estimate of what they would be if you put them together. But if we want to keep things accurate, this is the best we can do. We can't force them together. Example 6. You could always have something like this: the square root of 20 plus 2 square roots of 5. Now this is where things get a little more interesting. So 2 root 5, 2 square roots of 5, 2 times square root of 5 right here. That's already simplified. Square root of 20 is definitely not. 20 has multiple factors, and the one that comes to my mind immediately is 4 times 5. So what I mean by that is the square root of 20. You can think of that right now as the square root of 4 times the square root of 5. Yes, I skipped several steps right there. If you don't understand what I just did, you need to watch the simplifying video. So we get this, and this is just going to come down because again there's nothing to simplify there. The square root of 4 is 2. So you literally get 2 square root 5 plus 2 square root 5. And now you have a problem that you can do. It equals 4 square roots of 5. That is your answer. And I'll give you 3 of them. So the first would be 2 square roots of 27 plus 3 square roots of 3. What do you get? Second one, we will go with 4 square roots of 5 minus 7 square roots of 5. Word of caution, make sure you follow your rules. Third option, because we got to give you one that's a little more interesting, 5 square roots of 2 plus 16 square roots of 8. And honestly, none of these are as complicated as the simplifying the square root of 72 in the simplification video. So I'm moving right along to a multiplication. There's a reason why I'm going so fast with multiplication. It's because, well, it's the easiest one to do. So, and I'm not even saying that in a biased way. This is in fact the easiest one to understand. So multiplication 1, you multiply anything outside the radical together. These are your steps. Two, multiply anything inside the radical together, meaning your radicands. Step 3 is simplify. And then you're done. So you could have something like 2 times 4 square roots of 5. That does not have a radical. That's okay. 4 is outside the square root of 5. 2 is out here by itself. 2 times 4 is 8. And the square root of 5 stays behind. Example 2. 10 square roots of 2 times 5 square roots of 3. Alright, 10 and 5 are on the outside, 3 and 2 are on the inside. That's what you multiply together. 10 times 5 is 50. 2 times 3 is 6. Now notice on these, I can't simplify square root of 5, so I'm done. Here I can't simplify the square root of 6, so I'm done. Example 3 though, I picked one for you that is a little bit more challenging. So you get 5 square roots of 6 times 3 square roots of 3. Neither one of these can be simplified. And sometimes that throws people off because like these can't be simplified, but after you multiply them together, sometimes they can be. So if I multiply these together, 5 times 3 is 15. And 6 times 3, my radicands inside the square root is 18. 15 root 18. That is not simplified. The square root of 18, we got to work with that a little bit. So what winds up happening is you have 15 square roots of 18, and you can say, well, that's the same thing as 15 times the square root of 9 times the square root of 2, which is 15 times 3 times the square root of 2, which gives you 15 times 3, which is 45 square roots of 2, and that is your answer. Again, some of these calculators will automatically get you here even. They'll simplify for you. But when I give you a problem, I expect to see steps. All right, there you have it.